You know, the global market for counterfeit goods is a multi-trillion-dollar shadow industry, and the fakes, they are getting frighteningly good. They've absolutely mastered the packaging, the holograms, even the textures. On the outside, they're often perfect replicas. So the question is, how do you catch a fake when you literally can't trust your own eyes anymore? All right, let's just dive right in. Take a look at these two dolls. They're called Labubu, and they're a huge collector's item. One of them is the real deal, made by a company called Pop Mart. The other one? It's a cheap counterfeit. Visually, I mean, look at them. They're identical. The paint job, the feel, the box it came in, it's all designed to trick you. So how in the world are we supposed to know which one's the imposter? And that, right there, is the big question we're digging into today. The whole game of authentication has moved way beyond what we can see. We need a way to look beneath the surface to see the hidden truth of an object. And believe it or not, the answer lies in X-rays.
Okay, let's start with our first method. This one answers a really fundamental question. What is this thing actually made of? This is where we look right past the shape and the color and go straight to the atomic level to find an object's unique chemical fingerprint.
The technology is called Energy Dispersive X-ray Diffraction, or EDXRD for short. Now I know, that's a mouthful, but the concept is just brilliant. Every crystalline material, from the active ingredient in a pill to the metal in a battery, well, it scatters X-rays in a totally unique pattern. EDXRD reads that pattern, giving us a definitive chemical fingerprint that counterfeiters just can't fake.
So how does it work? Well, it's pretty much a three-step process. First, you hit the object with a broad beam of X-rays. Second, a super advanced detector reads the unique energy signature of the X-rays that bounce back from whatever's inside. And third, that signature gets matched against a database. It's kind of like running a molecular background check on the object. And this is where it gets really important. Think about fake pharmaceuticals. A counterfeiter could use a harmless sugar filler that has the exact same density as the real medicine. A normal X-ray, it wouldn't spot a thing, but their chemical fingerprints are completely different. EDXRD can tell instantly if you're looking at a life-saving drug or a useless sugar pill, even right through the packaging. Now, for this tech to be useful in the real world, it's got to be fast, right? And this is where a key innovation comes in. Researchers at University College London developed something called a fly scan technique that cuts the scan time by a massive 42%. That kind of speed is what makes it possible to screen products on a high-speed factory line, not just in some quiet lab. Okay, so EDXRD tells us what something is made of. But our second method, X-ray Computed Tomography, or CT as you probably know it, answers a different but just as important question. How is it built? This is where we look for the telltale signs of shoddy construction that counterfeiters just can't hide. Yeah, most of us know CT scans from the hospital, and the principle here is exactly the same. The machine takes thousands of X-ray images from every single angle and then stitches them all together into a complete 3D model. It's like having a digital blueprint of an object's guts, letting you just fly right through it and inspect every single piece. And a CT scan just lays the truth bare. You know, authentic products are made with precision, fakes are just thrown together. The scan exposes everything: hidden cracks, missing parts, dangerous assembly defects. It can even spot dead weight, like when they shove metal bars into a fake electronic device just to make it feel as heavy as the real one. Let's look at a concrete example. On the left, you're seeing the inside of real Apple AirPods. That's a tiny, custom-engineered, circular battery, designed to fit perfectly. Now look to the right, the counterfeit. They've taken a standard, cheap, rectangular battery and have literally crammed and folded it into the casing. That mechanical stress creates a massive fire risk right next to your head. And it gets even scarier with something like a lithium-ion battery. See, authentic batteries have this critical safety feature. It's basically a small internal buffer that prevents short circuits. You can see it there on the left. On the right, in the counterfeit, it's just gone. The internal assembly is a total mess. This isn't just a poor quality product, it's a potential bomb. And this is not a rare problem, not at all. A study that CT scanned over 1,000 batteries found that roughly 8%, that's about 1 in every 13, of the cheap counterfeit batteries had dangerous internal defects just like the ones we saw. And for the authentic brands, 0%. Not a single one.
So, let's bring this all together for the final reveal. We're going all the way back to that mystery we started with, the two identical Labubu dolls. Now that we have the right tools, we can finally see the truth.
So the crucial point here is this.
A real Labubu doll is designed to be posable. You can bend its arms and they'll actually hold that pose. To make that happen, the manufacturer engineers a specific internal skeleton made out of metal wire. And there it is. The X-ray reveals the whole story. The authentic Labubu has a clear, continuous aluminum wire armature right inside its limbs. The counterfeit, or lafufu as collectors call it, is totally empty. It's just stuffing, and that's it. That's why the real one holds a pose and the fake one is limp and floppy. The X-ray gives us a definitive pass or fail. Case closed.
So you can see this is about so much more than just catching fake toys or electronics. These technologies really do act as an unseen guardian for our supply chains, our safety, and our health.
Ultimately, it all comes down to this one powerful idea. No matter how perfect a fake looks on the outside, it cannot fake its own physics. It can't hide its chemical composition or its internal structure. A counterfeit may deceive the eye, but it cannot hide its atomic reality from the X-ray.
And that leaves us with a final thought. Counterfeiters will keep evolving. You can bet that artificial intelligence will help them create even more perfect replicas. So the question for the future is, as the line between real and fake blurs even further, what new senses will we need to invent to see what lies beneath?